Okay, class, good afternoon. Today we're going to be working on science. Do y'all remember what we were working on last time? Good job. We learned about gravity, right? Let's just do a quick review on gravity. These were your flashcards that you have. You should have them in your desk. You should already know them by now. We reviewed it last week, remember? So we learned about what force was, which is a push or a pull in a particular direction. That's the force that you use. And then we learned what motion, it's a change in position. Friction, a force between two surfaces that are sliding or trying to slide across each other. Okay, good job. And push. Push, using a force to move an object away from you. You all know what push means. If I push this chair, how can I push it? Would I go like this? No, like that, right? I would push it like this. Okay, good job. And then the opposite of push, which is pull, using force to move an object toward you, right? What I just did right now, I pulled the chair. And then lastly, gravity, which is the force that pulls objects together. And today we'll be learning about magnets. And magnets have a lot to do with gravity. We learned that for gravity, anything that goes up must come down, right? So anything in the world, it can be something super, super light as a feather, like the one we used, or we could have used the brick or a heavy rock. That one will also come down. If we throw it up, it'll come right down, right? Okay, well, magnets work something like that. Okay, the new vocabulary for today will be repel. Do y'all have any idea what repel might mean? Okay, it's something like that, but to repel is to push away. So I'm going to go ahead and write it down here. And you should be writing it on your journals as well, your science journals. And I'm going to put here, to push away. And then our next one will be, which is the opposite of repel, and it is attract. Attract means to draw toward. Okay, and then we have magnet pole. Magnet pole are the ends of the magnet where the force is the strongest. Okay, so I'm going to go ahead and write it down. End of the magnet where the force is the strongest. Okay, does anybody understand what magnet pole is? Yes? Okay, well, I have here a graphic organizer to show you for those visual learners. So all magnets have a north and a south pole. And we see here that opposite poles attract. So if we put the magnet like this with the south pole and the north pole, they will attract. So they will draw against each other. Like you see the arrows here, right? And then we have, if the same poles are together, they're going to repel. Repel meaning that they're going to push away. So you're never going to be able to have a magnet together with the north and the south. And I brought my little flower magnets, as you can see, the magnets. Okay, so let's go ahead and see if it's true. Opposite poles attract. So this is the north, and then this is the south. So I'm going to go ahead and put the south with the north, and it should attract. See how I did that? So I'm going to go ahead and now do the other way. The same poles, which the south with the south, and they're supposed to repel. And I can try to put them together, but they repel. You see? Okay? So you have some magnets there, so you should try it on your own. Go ahead and try it. And you're gonna see how you can try, right? You can try it and it never lets you, right? Okay, and our last vocabulary word will be magnetism. Magnetism, and everybody should be aware or know how to spell magnetism. Magnetism is the force of the repulsion, which is pushing, or attraction between poles of the magnets, which is the push and the pull. Okay, so I'm going to go ahead and to shorten it down, I'm going to just put the force of the repulsion or attraction. Force, so go ahead and write that down in your journals. Of the repulsion or attraction. Everybody writing it down? Between poles of magnets. Okay, so now that we know our vocabulary, now we're going to go ahead and start predicting. Okay, so you have your activity in your groups, so you should go ahead and start looking at it. You're going to be having, you're going to be sorting out first. So first you're going to sort out the magnetic and the non-magnetic. So you're going to go ahead and predict for now, because that's what scientists do, right? They predict at first before they experiment. So we're going to predict what we think is magnetic or non-magnetic. And first, we're going to, as you see, you all have this one as well. We're going to try all these things. And we're going to go ahead and report our activity. Okay, but today, you're going to go ahead and see me demonstrate just some things. So I'm going to go ahead and start with plastic. You have plastic on your handouts. Okay, so let's go ahead and see if it's going to pull it towards me. Nothing happens. So the plastic, you can check it off. You can go ahead and write a yes or a no, and you already observed, so go ahead and write it down. And now next we're going to go to the string. Which of you of your groups think that the string is going to go ahead and attract the magnet? Okay, that's good. We can predict. It's only predictions. We're not going to be right or wrong. Okay? So let's try it now with a string. And nothing happens, right? Okay, let's go ahead and... What do you think about the paper clips? Do you think these paper clips are going to attract it? Maybe, right? Since it's metal. Okay, let's see. How awesome is that? So, would you write a yes or a no? Of course, it would be a yes. And the last one is going to be pennies, okay? Money. Who says yes or no? Okay, let's go ahead and try it. It looks like metal, so it looks like it's going to work, right? And nothing happens. Nothing happens. Why do you think that the penny is not attracting the magnet? Or that the magnet is not attracting the penny? Why do you think? There must be a reason, right? What is the penny made out of? Of copper, right? So it's not metal. So something to think about is when it's not metal, anything is going to attract the magnet that is not metal, okay? No, it's